Here today in this lecture we will know how to compute the GCD of two numbers. Let's say a and b. Firstly, let's take an example. Say b equals to 24 and a equals to 18. Now we can write 24 as 18 into n times plus 6. If here instead of 6 it would be 0, then we could have said that 18 is a 18 divides 24 and the problem would have been solved. But here the 6 is the problem, so we will write 18 as some multiple of 6 plus 0. Here we have encountered the remainder as 0, so we can say that 6 is a multiple 18 is a multiple of 6, and here also 18 equal to 6 into n times. We will put here this, which will become 24 equal to 6 into n times plus 6, which will become 24 equal to 6 into n times, and we can say that 24 is also a multiple of 6. So here the GCD is 6. In this image I have tried to show the same example this way. We divide 24 by 18, we get remainder 6, and then we divide 18 by 6, we get remainder 0. Here b is 24 and a equals to 18. Now the a changes to 24, the remainder which we will get by dividing 24 by 18, which is 6, and b becomes 18, which was previously a. So here we get remainder as 0. Okay, and if we get remainder 0, then the previous a would be the answer. Let's take an example, another simple example. Say b equals to 75 and a equals to 24. So now we can write 75 equals to 24 into n times plus 3, and we can write 24 equals to 3 into plus 0. So here we can similarly say that the GCD of this equation is 3. So let's take look at a long example here, that b equal to 60 and a equal to 7. We will divide 60 by 7, we get remainder as 4, which now becomes a, and we divide 7 by 4. So here the 7 is b, which was previously a. So we divide 7 by 4, which gives remainder 3, which now becomes a, and previously a, which now becomes b, and this goes on till we get remainder 0. And the previous a was the answer, which would have now become b. So formally we can say that if a dash and b dash are the previous number, then mu a equals to b dash mod a dash. Mod function returns the value, the remainder, when b dash is divided by a dash, and mu b equals to a dash. So now let's see how the function of C++ will look like. So we write a function named GCD, which returns the GCD of two numbers a and b. So let's say if a equal to 0, then return b. Here we can say a now becomes 0, so we will return b, which was previously a, so which is 1, and this is our answer, as we can see. And as in another example also, we encountered a equal to 0, so the answer would be the previous a, which have now become b. Now else return GCD of, now A becomes B dash mod A dash, B mod A comma A, B becomes A. So here the percentage sign in C++ means modulo, which gives the remainder when B is divided by A. So let's say working of GCD of 24 comma 8, which will now return GCD of, as A is not equal to 0, which will return GCD of B mod A. So 18 when 18 when divided by 24 gives remainder 18, as 18 equal to 24 into 0 plus 18. So the remainder is 18 and which and A. So our A was 24. So now GCD of 18 24. So here also A is not equal to 0, which we will return 24 mod 18, which is 6, and which of A 18. Now here we will return GCD of the, here also A is not equal to 0, so we will return GCD of B mod 18 mod 6, which is now 0 and here 6. As now you can see A is 0, so we will return B, which is our answer. So now from this example you can see that if, like, by default we have assumed that B was a larger number, but if we give A as a larger number, then the values would be swapped and our new function will return as we have assumed. So this gives the correct answer when B is greater than A or A is greater than B. It does not affect our answer. So, and I can assure you that this function works a lot faster, and it will return GCD of two numbers in an instant. So that's all for this lecture.